Hey class, this is Mr. Roberts, and at this point, we should be getting to where we're kind of comfortable with coming up with the equation of any line, given that the situation we're looking at is linear, and we know some information. So yesterday or a couple of days ago, we did a problem that was called Down on the Farm, and on that problem, we were given, for example, the information that on day 9, after a chick was hatched, day 9, it weighed 98.4 grams. So the way that I wrote this, the way that I said this, the way the book set it up, right? Time was independent variable. These were days, days after hatching. And these was the weight of the chick in grams. Weight in grams. The other thing that we knew was that the chick had been growing. There's a couple of data points here at 5.2 grams per each day, per one day. And the question is, without creating a table, which we did, without creating a graph, which we also did, can you come up with the equation of the line that would go through that information, right? Uh, and Purely algebraically. So, of course, we were told to imply, although I think it's unreasonable, chickens would be huge if they always grew at the same rate. But maybe for the first, I don't know, 3 months or something, maybe it's reasonable. But assume that they grow at this rate, 5.2 grams per day. And then we did know that on day 9, the chick weighed 98.4 grams. So if we're if we're assuming linear growth, right, we're going to use a linear model to model that growth. So I write y equals mx plus b. And if I look at this closely, what I know is I definitely know my slope, right? I know the rate at which y is changing as x is changing. So I know my slope, right, is 5.2 grams per day. And I also know a particular x and a particular y value. I know that on day 9, right, when x is day 9, y was 98.4 grams. The question is, what's the equation that would model that situation? In other words, if I was to graph the point 990, a slope of 5.2 and a rate of and it goes through the point 998.4. So, I know a few things, right? I know a y value, and I could place that y value here. I also know an x value is 9, and I can place that here. And again, we've already said this. We know what the slope is, right? The slope is 5.2 grams per day, and I can place that there. One of the things this is actually students have kind of convinced me to do is look, I'm trying to solve this for b. I want b alone. B is not alone, but I could easily subtract mx from both sides. So if I took mx away from the left, it would be y minus m times x. And on the right, if I took away an mx, it would be just plain old b. So I know that b, my y-intercept, is the difference between two things. This y value that I have, right, and the product of my slope and the x value that I have. I think I can bring up my calculator here. There we go. That's great. Here's my TI calculator. And if I was to go ahead and just do that, my y value is 98.4. And from that, I'm going to subtract 9, or m rather, which is 5.2, times my x value of 9. And when I do, I get, that looks familiar, right? So when I do that, right, my y value minus my slope times my x value for that particular point, I get that b, my y-intercept, is 51, not 61. Looks too much like it. I can't take that risk. 51.6. And that would be 56.1 grams on day 0. All right, so now let's go ahead and type our equation back in Desmos. I lied, it's a GeoGebra, not that it matters. on this screen so that you can see, hey, I think if I'm given a point and a slope, I could definitely figure out the equation of a line. And then there's some other things we could do as well. That's all for now. This is Mr. Roberts. Have a great weekend.